So here is some big ugly integral. This is, but what is this? It's just how many people there are on the boundary, right? So we're going to call it M. And that's going to be the density of marginal consumers. Yeah, Eric.
Why is it negative? Okay.
Because when you raise the price, that reduces the number of people who are right? In some sense, this condition is U minus P is greater than 0. So it would be the effect of raising P would be negative 1. Okay. So the marginal users are those that have U equals P. And we're going to call the density of marginal consumers M. And how much does increasing N change P? Well, by the inverse function theorem, it's just 1 over how much increasing P increases N, right? So this was negative M, so this is negative 1 over M. Okay, so we're going to quantify the number of people purchasing the product by the fraction of the population that chooses to purchase it. That's just for simplicity. And we're going to call that N. And then the cost of producing is going to depend on the number of people we supply to and the quality of the product. And the firm is going to make profits, which are price times the number of people they sell to, minus the cost. Okay, so how do we find the optimal price for the firm? Well, we can just do the same thing we always did before. We can just say, if I increase the number of people, what's my marginal revenue? What's my marginal cost? The marginal revenue is price minus how much price changes when we increase the number of people. Sorry, price minus if we increase the number of people, how much price changes times the number of people. There should be N up here, not a P, sorry. And so we know that when we increase the number of people, price changes by negative 1 over M. And so we get just the standard term we have, P plus P prime times N is equal to marginal cost, which is how much the cost changes when we increase the number of people. Yeah, Maria.
What did you say that N was supposed to be?
Sorry, this is supposed to be N.
That's N.
Yeah. Okay. So the more that's exactly what we did in the Monopoly lecture. This is exactly the same thing. P plus P prime times N, which is now N over M, is equal to marginal cost. More interesting is what happens when we think about what's the optimal choice of the quality of the product. So let's first think about what would be the socially optimal quality of the product. To figure that out, we need to say, what is the social value created by the product? Well, it's the integral over all people who purchase the product of the utility that they get times the number of people that buy it minus the cost. Right? That's the total amount of social value created. Now, this is actually going to make things simpler in the long run, but it's going to require a little bit of work right now. I want the firm to be choosing the number of people and the quality of its product, not the price and the quality of its product. So I want to figure out how the price has to change when the quality changes so we can hold fixed the number of people. Why do I want to do that? Because I'm really not trying to say, like, how much quality do you choose overall, but rather how do you trade off choosing your price versus choosing your quality, right? Because we know, of course, that choosing your quality, increasing your quality is basically like reducing your price. But I really want to think about the trade-off between the quality and the price as ways to charge. Okay, so let's try to figure that out. So how can we determine how much the price has to change when we change the quality in order to hold fixed the number of people purchasing? Justin, could you help us try to figure that out? So how could we write down an equation that represents the idea that when we increase the quality, we're going to hold fixed the number of people? Well, what would that equation be? If the number of people doesn't change when the quality changes, how would you write that down as an equation? Anyone else want to try? Yeah.
Well, you would just write an equation that makes sure that the number of people remains constant. So it'll be a function of the number of people with respect to the quality of the product, and that derivative, the derivative of that function would have to be 0.
Yeah. So, in other words, dn d rho equals 0, right? And then we can use the chain rule to figure out what dn d rho is, right? There's two effects there, right? One is the direct effect of a change in quality on the number of people, and one is the effect that a change in quality has on the price times the effect that price has on the number of people, right? Now we know that the effect that a change in price has on the number of people is negative m times however much the price changes when the number of people changes. And then, does someone want to explain how I got this for the effect of the quality on the number of people? Yeah, Eric.
Well, you got that by like the Leibniz rule or whatever,
Yes.
right? But I'm just wondering,
Yeah.
so rho is supposed to be essentially a variable characterizing the product, right?
Yeah, the quality, the spiciness, whatever. Yeah.
But isn't rho usually like a multi-dimensional thing? So for example, for internet service, it could be the speed of the service as well as the quality of the service, right? Like
I agree, but I think we should take a show of hands of how many people want me to write this all in terms of matrices rather than writing it in terms of a single value.
So basically we're just condensing the multivariable format.
It's not possible to condense a multivariable thing into this, but the truth is that literally everything I'm going to show you is exactly the same in the multidimensional case, except you'd have a matrix. And I just don't think anyone here wants to have matrices floating around. So that's why I'm doing this. But you get all the intuition for the multidimensional case out of this. It's just that you have to use matrices to characterize the multidimensional. It's similar to like in physics why you often do things in like 2 dimensions, even though the world is 3 or 4 dimensional, just because it's simpler and you don't have to keep track of as many things. Okay, so I got this by Leibniz, like Eric said. Eric, do you want to explain why it's exactly this formula that comes out of Leibniz?
Well, if you look at the value up there.
Well, we're taking the derivative of the number of people, so this is this, right?
Right. And like the formula you had for the value, that was I think it was on the next slide.
Yeah. But we're not using this one yet,
No.
right? Because we're just we're saying what's the derivative of the number of people with respect to rho. So just derivative of n.
Okay. Well, regardless, so in there, right, the utility like has to of rho, semicolon thing, has to be greater than or equal to p. So when you take the partial derivative with respect to rho, obviously the function of theta is unaffected.
Yeah.
And so what changes is essentially the boundary, which is the marginal value of rho.
Yeah.
Which will determine whether or not they're in it, which basically means u of rho theta has to equal p.
Yeah, so what happens is when you take the derivative under Leibniz along the boundary, you have to take how the boundary changes with the change in the variable. So when we increase rho, this changes by u prime. So we have to bring that inside of here, and we have u prime times whatever is inside integrated along the boundary. And that's exactly what we have here. So it's the integral along the boundary, along the set where u is equal to p, of u prime times f. Right? Okay. So, that's trick number 1. Trick number 2. What is it? We take a messy expression and we give it a name. So, what's the messy expression? I don't want to be carrying that around, right? But what is this? Well, it's the integral over the set of marginal people who are on the boundary, of their marginal utility times the number of people. Well, that's the same as the number of people times their average marginal utility. So let's call u tilde, I'm going to use tilde to denote the average value of something for people who are on the boundary, who are marginal. So that's going to be u tilde prime. U prime tilde, sorry. U prime tilde is the average marginal utility for someone who's on the boundary. Right? Okay. So then, we can go back to our expression here. We have negative m times dp d rho plus this thing, which is m times u prime tilde. Dividing through by m, we get dp d rho is equal to u prime tilde. And that's really intuitive, actually. Imagine that I increase the quality of the product, and I want to hold fix the number of people. I'm going to have to raise the price by the average value that people put on that quality, right? Otherwise, people are going to come in or come out. Okay. So, that now allows us to take the derivative of social welfare up here with respect to rho. And Leo? Is Leo here? Read ping? No? Does someone else want to try to take that derivative? Using Leibniz's rule and what we just figured out? So there's going to be two effects, right? One is going to be the direct effect of rho, but then rho also changes the price. So you're going to have to use Leibniz's rule for each of those two effects. Okay, I'll go ahead and do it. So, what are the two effects? Well, first, we're going to take the derivative with respect to rho. What do we get when we take the derivative with respect to rho? Well, we get some effect on this, and that's Leibniz's rule. So we have to take the boundary and the interior, right? So along the boundary, we get the integral over the boundary, except where u equals p, of u prime times the interior, which is u times f. Right? Okay. Then we have to do the interior, which is the derivative of u, and integrate that over the whole set. So this is over the whole set of participating people, or purchasing people, of u prime times f. And then minus c sub rho, which is the marginal cost of quality. Then, what happens? The price is going to increase too, right? What happens when the price increases on this? Well, again, we have to, that only affects the boundary, so we're going to get negative integral along the boundary of u f, right? Times how much the price changes, which is u tilde prime, u prime tilde. Okay. Now, notice that u here is equal to p. That's what we said, right? These are the people who are just indifferent. The people whose utility is exactly equal to the price. So we can cancel this out and write p there. Right? And that's true for these guys too. So this whole expression becomes p times u prime f. But what's u prime f over the boundary? That's just u tilde prime times f. And this here is exactly m. So these two things cancel with one another. Why do those things cancel with one another? Because we're holding fixed the number of people. And so people aren't coming into or out of the market. Right? And so that's exactly why I made you go through this whole thing of holding things fixed. Because then these things cancel, you don't need to worry about them. And all we're left with is this. What's that? Well, this is the marginal utility given to all the people who are still buying the product by increasing the quality, integrated over all the people who are buying the product, minus the marginal cost of the quality. And again, what do we do when we